Okay, guys. This example, a rectangular garden is 8 feet long. If you walk diagonally across the garden, you would walk 10 feet. How many feet wide is the garden? You'll see a question like that. So let's go over how you can answer this question using the example, one of the examples that I showed you of Pythagorean theorem, which has the formula that of a squared plus b squared equals c squared that I showed you earlier. And then afterwards, we'll go over this second example here, okay? The way you approach this example is what we read was that the rectangular garden, okay? So this is a garden in the shape of a rectangle. That's why they use the word rectangular garden. It said if we walk diagonally, which means if we walk this way, diagonally, okay? If we were to do that, then we would find ourselves walking 10 feet. So this is 10 feet is what they're saying. Okay? And but the rectangular garden though is 8 feet long. They did say that. So if it's 8 feet long, okay, and then if we walk across, it's 10 feet. Remember, with Pythagorean theorem, as we mentioned earlier, the longer side is always C. This is always C, okay? A, B, and the longer side is always C. So using the a squared plus b squared equals to c squared, the way we approach this problem, it would be a squared plus, instead of b squared, we would put 8 squared, because that's b is 8, and then c is 10, so it would be 10 squared. So that's what c would represent. So then we would end up with a squared plus 8 times 8, which is 64, equals to 10 times 10, which is 100. Okay, so then we do our subtraction because we're trying to solve for a. Subtract 64, subtract 64. Okay, so a squared now is equal to 100 minus 64. That would be 36. Okay, so to solve for a, we would take the square root of the left side, square root of the right side. So this becomes just a equals to square root of 36 is 6. So this portion is 6 feet. Okay, so the answer would be 6 for A. All right, so real quickly, let's also take a look at this other example that you will see. The last problem was a word problem, but you may see something like 7, let's say 7y to the 4th power, square root of 121y to the 9th power, okay? And then you may see something like x to the 4th power. So you may see something like that, okay? And you ask to simplify. And this is the last example that I'm going to show you in terms of simplification. So as we've showed you, so 7y to the 4th power, you wouldn't do anything with that yet. So this part you will rewrite, the square root part. So 121 is basically what? It's the perfect square of 11 times 11. Okay? So for the y to the 9th power, this is y times y, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9. So y to the 9th power, and then x, 1, 2, 3, 4. X times x times x times x 4 times. So then if we look, we notice that we have a pair of y already. I'm sorry, a pair of 11, 1 pair of y, 2 pairs of y, 3 pairs of y, 4 pairs of y. This is by itself. And then 1 pair of x, 2 pairs of x. So this we can rewrite as 11. We're gonna pull out 11 because we have a pair. 11 times 7, that was already out in the outside. So for the y, we're going to write y. How many pairs we have? 1, 2, 3, 4. So instead of y to the 4th, now it's going to be y to the 8th power. Okay? So what about x? We didn't have any x, but it's going to be x squared because we have 1, 2 pairs of x. So square root of what is left here, I don't even need such a big square root because only one y stays, and that is the final answer. And we've covered everything that you will see in the mock final and the final. Best wishes. Thank you.